Good evening, students. I anticipate that these will be the notes for Tuesday's class. Over the next several days, we're going to spend time looking at the four transformations that you have already been exposed to in junior high. And we covered towards the beginning of last week the translation, rotation, reflection, and dilation. We're going to see how those apply in what is referred to as the Cartesian coordinate plane. So let's begin. Our objective today will be the student will learn to apply translations to objects in the Cartesian coordinate plane. Again, I anticipate that these will be the notes for Tuesday's class, and unless I'm mistaken, that date will be October 1st. As always, pause the video anytime you need extra time, and then press play when you're ready to begin again. Okay, now a little bit of basic vocabulary here for you. The name for the XY axis that you have been graphing on for years has an official name that is named after the person who developed it, and it is referred to as the Cartesian coordinate plane. This is vocabulary that you do need to get memorized. It is not unlikely that you will hear the Cartesian coordinate plane referred to in that language by questions that you may run into in the future. Now, a term that we've already discussed this year, any location in the Cartesian coordinate plane can be precisely plotted by the use of what we call an ordered pair. Now, an ordered pair it provides two pieces of information. One piece of information that tells us how that location lines up with the x-axis, and then another piece of information that tells us how that location lines up with the y-axis. And of course, we place those two values inside of parentheses separated by a comma. Now, the x and the y values in the ordered pair have official names as well. And while you may be familiar with the first two terms, I find it unlikely that you have heard of the names for the actual x and actual y. Now, you've heard of terms like domain and range to describe x values and to describe y values, but those aren't the names that these are actually referring to. Okay, the values x and y are actually called the abscissa and the ordinate. Now, this is kind of remote language. Like I said, I don't expect that you have heard of these two before, but you will run into questions from time to time that will refer to an abscissa or refer to an ordinate, and you need to know that those are synonyms for an x value and a y value, because ultimately those are pretty easy questions to answer. But if you're unfamiliar with the vocabulary, just like a lot of things in geometry, you will find yourself not knowing how to answer a question, even though it's an easy one, simply because you do not understand the language. So these terms need to get onto your vocabulary list as things that need to get learned. We will be working with these two terms over the next few days. Because performing transformations in the Cartesian coordinate plane will involve various changes to the abscissa and the ordinate. In some cases, it will call for their signs to be reversed. In some cases, it will call for them to be reversed. And in some cases, they just change kind of on their own. And we'll discuss all of that over the next several days. Okay, now a basic rule when performing transformations of any kind within the Cartesian coordinate plane. Now you may be familiar with this, maybe not, just depends on who you had as a teacher in junior high. But let's take a look. We've already used the term with our transformations of pre-image and image. A pre-image is a figure that has not been altered yet, but after a transformation takes place, we then refer to it as an image. So a pre-image has points in a graph or in a figure that are labeled as capital letters. This is to be expected because we said that points in Euclid's geometry are named after capital letters. However, once a figure has undergone some type of a transformation, be it a translation, a rotation, a reflection, or a dilation, it becomes an image after the transformation has been performed. Once you have an image, they label the figure and they mark them with a prime mark. And it's in the punctuation world, it's what we call an apostrophe. Okay, but in the mathematical world, it's called prime. So quadrilateral A, B, C, D above undergoes some type of a transformation and becomes quadrilateral A prime, B prime, C prime, D prime. Okay, and if quadrilateral A prime, B prime, C prime, D prime were to undergo some further transformation, then we would use more prime markers like A double prime, B double prime, and so on. And by the time this is all over with, you will see that a lot of times it is not that one of the transformations has occurred, it is that several transformations have occurred to get from an image to several pre-images, because when they do ask us these questions, they usually do not simply say reflect this object or rotate this object. They will say reflect it, then rotate it, then translate it, and then ask you about the image that results. So you have a bunch of different translations or transformations going on at once, and that's where these questions can become challenging. Okay, so we're going to start off here with an example and a basic definition for translations. Now we know that translations from our basic definition means to simply relocate an object, and that is simple enough in its concept. However, when you put it in a graph, it becomes a little bit more scientific. Okay, but translations work very much the same as slope works in a graph, meaning that each point that is being translated moves with the same rate of change. So in other words, if we can figure out how one point moves accurately, then we can simply move all of the other points by the same measure of accuracy, and we should end up with the proper image. So in the figure, the graph that you have here, we're given an instruction to translate triangle ABC 6 units right. And then the questions at the bottom are what are the coordinates of the new triangle? And of course, we start off with an image being triangle, or a pre-image being triangle ABC. We will end up with an image triangle A prime, B prime, C prime. Now, just moving through it simply enough, translate triangle ABC 6 units right. This is similar strategy to what I gave you for reflecting an object. Do not try to move the entire figure all at once. Pick it up one point at a time, move it one point at a time, and if you do that, it really becomes very difficult to actually miss anything. So I'll start off with point A here, and I'm simply going to, as the instructions say, translate point A 6 units to the right. And when you do that, basically we end up with a new point, which is now A prime, that is 6 units to the right of where A was. We repeat the process for point B to get to B prime, and repeat the process for point C to get to C prime. Once you have the pertinent corner points moved, what are called vertices, you can connect the dots, and you can see very clearly we have the new triangle. From there, we can figure out what our coordinates for A prime, B prime, and C prime are. We'll take a look at point A. What is the coordinate for point A prime? I meant to say A prime. What's its coordinate? Okay, it lines up on the x-axis at 0, the origin, and it lines up with the y-axis. Obviously, it's sitting on the y-axis at 2. So the coordinate for A prime is 0, 2. The coordinate for B prime, well, look at B prime. Where is it at? It lines up with the x-axis at positive 2, and it lines up with the y-axis at positive 5. So B prime is at 2, 5. And C prime, where does it line up? 3 on the x-axis. I'm sorry, 5 on the x-axis and 3 on the y-axis. So C prime is at 5, 3. So really very simple concept. It's not a big deal. I think the thing that people get in trouble with on translations is getting into too big of a hurry. You just take it one step at a time and one point at a time. Really very difficult to mess it up. Okay, but as I said, sometimes our problems have us do more than one transformation at a time. Okay, so now we're going to take triangle A prime, B prime, C prime, and our instructions are to translate it so that B double prime will be on the origin. And this is usually the way translations go in a graph. Very seldom do they let us just move a graph sideways or vertically. They usually make us move it on some kind of a diagonal. Okay, so that's what they're having us do here. Okay, they want B prime to go to the origin. Well, that's pretty self-explanatory. In order to go to the origin, B prime must move down 5 units and back 2 units. Okay, so essentially its rise over run is -5 over -2. The negatives cancel, and you actually get a slope of +5/2. Okay. Well, there's where B double prime is going. That's where the instructions told us to move it. But if B double prime must move by a slope of -5 over -2, then A prime and C prime must do the same to arrive at those locations. So you can see our 3 points, A double prime, B double prime, and C double prime. And from there, we can connect the dots, and we have the resulting image. So at the bottom, what are the coordinates of the new triangle? Well, where is point A double prime? A double prime is at -2 on the x-axis and -3 on the y-axis. B is sitting on the origin. That is a very easy one, 0, 0. And C double prime, where is its location? +3 on the x-axis, -2 on the y-axis. I've got an error in my notes right there. I'm going to fix that while you're looking at it real quick. Okay, so there we go. And that is the location for C double prime. Okay, and again, very difficult to mess these up, except for me having typographical errors in my notes. Very difficult to mess these up. If you take your time and do it one point at a time, really becomes quite difficult to miss anything. So when you arrive at class on Tuesday, we will be working off the wall with our graph, and we will be translating some polygons from those points and seeing if we can't figure out some stuff. So I appreciate you tuning in to take your notes. I will see you in class on Tuesday.